Welcome in. Greetings, everyone. Happy Wednesday. I hope everyone's doing hosting this stream for math help and trying to make that a priority. And then in the meantime, if I don't have students, I'm just going to be trying to work on practicing presenting a topic about graphing and working towards trying to get it in a very concise manner. So I know that I'm a little bit slow out of practice, but this is me trying to make the most of my time in front of the camera with my board, and yeah, just playing around with the math and getting used to trying to explain the math while I'm working it. So I got a little discouraged yesterday when I was graphing the vertical hyperbola because I decided to try to use this function, this form of the function to evaluate the graph. So I'm going to kind of play around with this form for a little bit to start out. And then hopefully I won't spend too long on that. And I'll move into the graphing of the ellipse. So basically not quite ready to move on from hyperbolas. I just want to see if I can rearrange this one. I got close here, and I think if I wanted to, I could go ahead and keep this one to make it a little bit easier. But I think what I did was I plugged in a value for x and tried to solve for y. And I'm trying to remember if it was 0. That's typically how you would find these zeros here, is you would plug in 0 for x here, and then you would solve this thing for y. So I guess we could do that. That might not be as difficult. So I'm going to go ahead and erase some of this, and then continue talking about the conic sections. The only other conic section that I haven't graphed yet on my board during this project has been the ellipse. So I do want to go ahead and finish off the conic sections and go ahead and play around with eventually the graph of the ellipse. So we'll finish this, and then that is the plan. So I will just go ahead and get right into it. I'll leave the graph up so we can visually see where we're looking for these values right here. This one and this one. Where is it crossing where is it actually crossing the x-axis? And remember, we were using this graph to plot these points. This was that generic graph that we had to shift. We were shifting that direction 3 and up 3 is what we were doing, that graph. But we didn't get to actually find those zeros. We could actually plug in when x is 0 here and see what happens. So we'll just say y minus 1 quantity squared divided by 4 minus 0 minus 3 quantity squared over 9, and that equals 1. I'm going to write smaller. And then, see, I'm going to go ahead and expand this. I did it yesterday too, but this is y, and I've explained how I got this, but this is y squared minus 2y plus 1, and then it's all over 4. We'll keep that denominator. And then that is minus negative 3 squared is positive 9. Positive 9. And that is over 9, and that equals 1. So that is anything divided by itself is equal to 1. So you'll end up with y squared minus 2y plus 1 over 4. And then what we're going to do is we're going to add the quantity 1 to both sides, plus 1. And so that's going to give us this expression, and that equals 2. So to get rid of this 4 in the denominator, to eliminate 4, we have to multiply both sides by the quantity 4. So we'll do that. And it's going to give me 4y squared minus, and all we're doing is taking that 4 and distributing it across each term. So 4y squared minus 4 times negative 2, that is negative 8y, and then 4 times 1 is plus 4, and that is going to equal 8. And then what we're going to do is we're going to go ahead and move the 8 back over and set this equal to 0, because this is a quadratic, and we can solve it if it's set equal to 0. That's how we're going to find the zeros. And so we'll just do that by subtracting 8 from both sides, and it's going to give me 4y squared minus 8y, and then negative and plus, that's going to end up with a negative. Signs are, when the signs are different, you're going to subtract, and then you're going to keep the sign of the larger one. So that's the rule. And so it's going to be negative 4, and that equals 0. All right. So since I can now factor out a 4 from this expression, okay, that's what I want to do. I'm going to go ahead and divide off 4, because if you divide, let's see, each, all right, so I can divide, well, let's do it like this. Let's factor out a 4 from this expression and see what happens. So let's not divide yet. Let's just say 4 times and rewrite this. So it's going to be y squared. 4 times 2 is 8. So that's going to be 2y. And then 4 times 1 is negative 4. So that's going to be negative. And so we've got the 4. If you divide both sides by 4, which is a legal operation, 0 divided by 4 is just 0. So you ended up with this polynomial that I'm pretty sure that's just this one, right? Oh, minus 1, it's not plus 1. This one might not factor. So we have y squared minus 2y minus 1 equals 0. And this one is not going to factor because it's not, see how close we are to producing this one, but we can't. So what we'll have to do is I am going to use the quadratic formula. Why don't we complete the square on this one? Let's go ahead and complete the square. So completing the square method, y squared minus 2y. And then what you're going to do is you're going to add 1 to both sides. And then leave some room. And you're going to get 1 on this side, that goes to 0. And then what you're going to do is you're going to use the additive property, and you're going to come up with a value you're going to add to both sides. So you're not going to change the value because you're going to add the same quantity to both sides. But on this side, you're going to have a perfect square. And how you find that perfect number A special number is a method. So it's a two-step method. So you take that middle term, that linear term, -2, just the coefficient, and you're going to divide it by 2. And so, see, -2 divided by 2 is -1. And then what you're going to do is you're going to square that number. And that's going to give you a +1. Okay. That number is the one that you're going to add to both sides. The number inside the number as a result of dividing it before you squared it is the number that makes your perfect square. So whenever you condense it, you can now say y minus 1 y squared equal 1 plus 1, which is 2. So I'm going to erase that word because in our way. And my dog, I don't know if I'm going to have to interrupt the live stream to settle him down or not. All right, please excuse my canine. Yeah, anyway, you can hear that. He's very entitled. All right, so what we're going to do now is, okay, so I just did that and I didn't explain what I'm going to do. All right, so now that I've got it in condensed form here, what I've got to do is, I've got to solve this for y, and so what I have to do is I have to think of order of operations, and I have to get rid of the square. So to remove that square, I'm going to take an inverse. I'm going to perform inverse operation, and I'm going to do that same inverse operation to both sides. And so what that's going to do is now that's going to give me what's on the inside of this. It's going to remove those radicals. The square goes away and the radical goes away. And you're left with y minus 1. And the tricky part is that one of these square roots has got to get negated, because when you take the square root of a number, you end up, and because of the shape of the graph of the square root function, you're going to get a positive and a negative value. All right, so we're almost done solving for y. We've got y, and what we're going to do is we're going to add the quantity 1 to both sides, and you're going to get y equals plus or minus, or I guess it would be, sorry, we'll move that 1 in front, so it's going to be 1 plus or minus the square root of 2. And so it's going to lead to 2 y values, just like we expected it. We've got y equals 1 plus the square root of 2, and y equals 1 minus the square root of 2. So we have 2 y values when x is 0. Now I'm just wondering how that's possible, because the square root of 2 is only 1. So that's same with the graph. So this one would go negative. Anyway, this is how you would evaluate the graph of the function. For some reason, probably want to plug this into a graphing calculator and check it, because I don't know if it's accurate or not. But I know that's like not really satisfying. But I spent 15 minutes on this problem and already, and so I feel like that's enough time. The algebra and the method is the same. It's probably correct. When you're dealing with these rough sketches, that's what you're going to get. It's a rough sketch. So, okay, very good. All right, so I'm going to go ahead and erase everything, and we're going to start talking about ellipses. And an ellipse is sort of like, it's a smushed circle. So it does have symmetry, but it doesn't have perfect symmetry. So if the radius is not equal all the way around the ellipse, but it does have it has a major and a minor axis of symmetry, and has a vertical or horizontal orientation. And what I did was I went and learned definitions, and refreshed on definitions of what we needed to graph one of these things. Again, I'm not an expert by any means. I just enjoy math, and I feel like that I have learned enough math that I can maybe confidently explain and encourage students. So I'm not trying to say that by any means I'm an expert or anything like that, but I mean, I know a little bit. Anyway, yeah, this marker is going to be too squeaky. And then I think one of them was a dead marker, and I forgot to throw it away. So hopefully I threw it away. Oh, this one's perfect. Okay. So I'm hoping that this won't take too long. And it's like doing math in the evening is dangerous. I feel like I would probably be much better at it the first of the part of the day, but that's what we're stuck with. So just make the most of it. All right, so I am going to start out with this ellipse in general form. Okay, and we'll say 4x squared plus y squared. I tried to get it really big, the example, so that I can kind of see it from my monitor. Trying to learn and improve. It's the little things, the little things. All right, so there is theory behind looking at a graph, or not a graph, but an equation in general form, and trying to determine what kind of conic section that it is. And so what it involves is so what you're doing is you're taking it from this form. This is almost like polynomial form. And you're going to convert it into that standard form. So we're going from general form to that form that we were playing with yesterday. Very similar. The equations for ellipses and hyperbolas are almost identical. There's just a couple of minor details. Okay. So what you do is you change the form, and that requires us completing the square method, and we're going to use it twice. So what we're going to do is we're going to use it's slightly different from solving an equation. We're not solving for a particular value, we're rearranging the equation. So what we want to do is we're going to take, and we could put that other form up here if we needed to. So let's go ahead and do that. See if I can write it up here pretty small. It was x minus h y squared over a squared, and that was plus y minus k quantity squared over b squared, and that equals 1. And depending on whether a or b is bigger is, so this would be a, hang on, a or b. And this is a or b squared. So it's depending on, so A is always going to be bigger than B. So this is something else I figured out. So A is going to be bigger than B. So whatever their bigger number is, you have to just pick it for A. Whatever. And I'll show you what I'm talking about when we get down to it. But we are going to go ahead and rearrange this, and I'm going to group the x value variables and the y variables separately. And then I'm going to go ahead and move the 16 to the other side. And it's going to be 4x squared minus 16x. And I'm going to even use parentheses. I'm going to say plus parentheses y squared plus 4y, leave some around, and then subtract the 16 from both sides. And that's going to equal negative 16. And then whatever number that we have for square, what we're going to have to do is we're going to have to make sure whatever we add to this side, we have to make sure we add to this side as well. So this one, we have one extra step because unfortunately 4, it does not divide, or it doesn't, the coefficient, leading coefficient for completing the square method has to be 1. So it can't be 4. So we're going to go ahead and pull 4 out of that term. So that's going to be x squared. 4 times 4 is 16. And then we're going to leave some room, and we're going to have 2 parentheses on that one. All right. Plus, in parentheses, I've learned to really appreciate them over the years. It really helps you to keep track of your operations, and whenever you're row reducing your and simplifying each step, if you make a mistake and you don't catch in that previous step, it's very tragic because you do all that work, and you know, especially when you get up into upper level math, you work the whole thing out and it's taking you a couple pages, and you know, you learn to kind of take care of that and make sure that it's like you're doing your brain a favor, making sure that you have it as neat as possible. All right, so now that completing the square method, we're taking that middle term, negative 4, and we're going to divide it by 2. And that's going to give me negative 2. And then I'm going to square that number. It's going to give me a positive 4. And I'm going to add it here. And I'm going to multiply it by 4 before I add it here. So 4 times 4 is 16. So I just, in theory, I added 4, but it's 4 times 4, so it's 16. So we have plus 16 here. Okay, I know that's kind of weird, but I'm not just adding 4. I'm because remember that was 16. So we still have to add the 4 back to the middle term. We're going to have to add it here as well. So we're going to say 16. And then we're going to repeat that process here, the same thing. So we're going to take 4, it's positive 4 this time, and divide it by 2. It's going to give me positive 2 squared is going to give me 4. So we'll add 4 here. And we didn't have a coefficient to mess with here, so this is just adding 4 here as well. All right, good. And so what we have here, before I erase these two, I can put one more step in here. This is 4 times x minus 2 y squared plus y plus 2 y squared. And then 16 minus 16 is 0, plus 4 is equal to 4. So let me go ahead and erase this because I don't need it anymore. This was just that completing the square method. Leftovers, we can erase that. So now we have this thing going on. So what we have to do is, for it to be in this form, okay, for it to be in this form, we have got to make sure that this number right here is 1 and it's not, it's 4. So what we have to do is we're going to divide both sides by the part of 4. And in doing that, we're going to end up with 4 times x minus 2 quantity squared divided by 4 plus y plus 2 quantity squared divided by 4. And that is going to equal 1. And then you got to reduce these down. This is going to reduce down. So you end up with, finally, it's going to be x minus 2 quantity squared over 1 plus y plus 2 quantity squared over 4 equal 1. And so we're looking here, and do you see how 4 is associated with y, and it's bigger than 1? So we have got to pick A to be with y, so B is going to be with x. So A equal, so A squared equals 4. So taking the square root, you're going to get A equal 2. And then B is going to, B squared equal 1. So taking square root, you get B equal 1. And so we're going to take, it's going to be of this form. Okay, so it's going to be x minus h quantity squared over b squared plus y plus 2 y squared over a squared. And that's going to equal 1. And then so since it's in this form, that's telling you that I believe that that is going to be a vertical. That'll be a vertical, pretty sure. Vertical ellipse. But h, it's -2. So it was h and k. So then your center is going to be at your h comma k. It's not plus, it's minus here. Sorry, one mistake. All right. I'm pretty sure your form is negative. I'm going to double check on that. Where do I have that written down? Because still pretty fresh. I just have to double check and make sure. Did I not bring that in here? Let me look it up. I have Google at my fingertips. going to be a vertical ellipse, and yes, these are this is correct. So it's going to be vertical. And the center is going to be, so if the form is negative and your value is negative, then it's a positive value because you're not having to do any math to get it. It's just, it is what it is. So you can just pull that value. If it's a positive and your form is negative, you've got to think 2 negatives make a positive. So it's leading you to a negative k value. So that's going to be -2. So here's your center, and it's vertical. It's got a vertical orientation. That means that the major axis is going to be along, is going to be parallel with the y-axis. All right, let me go ahead and get my Cartesian coordinate system out. Let's see if we can sketch one of these real quick. And we'll start by locating that first critical value. So we've got y and x here in our origin. And our center is at 2. So let's say 1, 2, -2. -1, -2. So 2, 2 right here. There's a center. And then how did I not bring that? I mean, where is it? So I'm going to try to remember from memory. So A is the major axis. Okay, so you find the length of the chord. So the major axis, all right. So you have this thing, the major axis and minor axis. And the major axis is going to be your A value. So it's going to be 2A, I think, 2A. And then your minor axis is 2B. 2B. So we've already calculated A and B here, A and B. So 2 times A is going to be 2 times 2 is going to be 4. So it's the length of 4. And then your minor axis is 2 times 1, which is 2. So we have the way that you figure out your ellipse, since it's a vertical orientation, it's going to be 4 units. 4 units long and 2 units, only 2 units through the center. So I believe it's 2. Because what they're saying is, let's see, A was 2, right? Okay, so we're going to go to this direction and then to this direction. And it's saying our major chord is going to be from here to here. Okay, I drew that really thick. And then B is only 1 unit. So it's saying from here, that is a really small ellipse. Is this, and then to here. So this is 1 to 3. It's saying these are points on that ellipse. So I think that's entirely possible that that's it. But I almost want to graph this now. I wish I would have. But the values are not that great, so that makes sense. If we wanted to go ahead and just check one point in there, I guess we could. Let's see, we found the center. Yeah, graphing an ellipse. That was a lot easier than I thought it was. There's also the focus. Um, well, I mean, that's 40 minutes. So, I mean, I guess since I don't have any questions in the chat so far, it's 40 minutes. I guess I could call it good and stop early. Or it just seemed too easy, like I'm getting off too easy. Yeah, I guess that wasn't a real exciting graph, but it'll do. Yeah. We'll at least make something else in the other quadrants really quick and just, yeah, I guess I'll go ahead and stop there. I showed quite a bit of algebra and, you know, finish Wednesday midweek off a little early. So, yeah, again, if you need help with your math and just don't be shy, maybe. I know it's hard for me to say because I've shied away from the camera and social media for most of my adult life. And so I understand. But if you need help, um, there are no really that cliche saying that there really are no stupid questions. That's the truth. There really aren't. There's just some really, really dumb answers. But yeah, again, if you watch my videos and you know you're finding them somewhat helpful, I really appreciate it. And if you want to see me, I'll be back again tomorrow. Same time, same place, between 6 and 7 p.m. Central Time right now. And I look forward to coming in tomorrow to hang out again, and we'll see what I can come up with as far as, yeah, the graphs. Maybe we'll move on from conic sections. I haven't really decided yet. So, again, I hope that you have a wonderful rest of your evening, and I will see you again tomorrow. Bye.